Limits of simple trigonometric functions.
Hello everyone, today we want to look at the limit of a simple trigonometric function. The limit of a simple trigonometric function. So now, limit is simple. Limit as x approaches a of a function of f(x). So now what I want to look at here is that I want to look at the function of f(x) equal to sine x, if the function of f(x) is equal to sine x, or if the function f of x is equal to cos x, or if the function f of x is equal to, let's say, sine x on x, or if the function f of x is equal to what? Tan x. But always take note that tan x is the same as what? Sine x all divided by what? Cos x. Okay, so these are the basic four things we'll be looking at, how to find the limit of these functions. Now, we want to look at finding the limit of the sine x, cos x, sine x on x, or tan x. But the x we are looking here should be measured in radians, where the x is measured in radians as x approaches 0. So we are looking for these functions where x is measured in radians as x approaches value for values which are less than, for values. So we are looking for values which are less than pi on 2. Which are less than pi on 2. That is the pi radian on 2. Okay, so now for f of x equal to sine x. For f of x equal to sine x, let's take random values as x is approaching 0. So random values like x, and let's see the function sine x over here. Now let's take values like 0.8, and the x is approaching 0, 0.2. Let's take 0.1, 0.01, and let's take 0.001. Okay, I think this is okay now. Now what happens, what we want to do is that we've taken this function as f of x is equal to sine x, as x is approaching 0. So as x is approaching 0, what will be the limit of the function sine x as x is approaching 0? Now when you plug this with your calculator, sine x here will give you 0.717. The 0 here will give what? 0.198. This will give you 0.0998. Here will give you 0.00998, and this is 0.000998. It continues like that. So now what we can see here is that as s approaches 0, or as s is decreasing to 0, the value of the sine x is also approaching what? 0. So as s approaches 0, the value of sine x is also approaching 0. So what we can see is that then the limit of sine of x as x approaches 0 is equal to 0. The limit of sine of x as x approaches 0 is also equal to 0. Okay. Now for the same values, let's look for cos x. So this is the first thing we've established here. Let me put it here. So therefore 1, the limit of sine x as x approaches 0 is equal to 1. Is 0. Okay. So now let's look for cos x. If x is what? Cos x. Now, if it is cos x, for 0.8, we'll be getting 0.697. For 0.2, we'll be getting 0.98. For 0.1, we'll be getting 0.995. We'll be getting 0.999995, 0.9999995. So now for cos x, what can we see? You realize that as x is approaching 0, the cos x is increasing, approaching 1. So now the limit of cos x, always as x approaches 0, is 1. That is the limit. So 2, the limit of the trigonometric function cos x as x approaches 0 is 1. Okay. Now let's look at the last one. We want to look at the limit, the function sine x all over x. Okay. Now, if you look at the function sine x all on x, for 0.8, so sine 0.8 over 0.87, that is x measured in radians for values which is pi on 2. For 0.2, you'll be getting 0.993, 0.1, you'll be getting 0.998, you're getting 0.9998, you're getting 0.99998. So you also realize that as x approaches 0, then the function sine x on x is also approaching 1. So therefore the limit of sine x on x as x approaches 0 is also 1. So the third thing is here, limit of sine x on x as x approaching 0 also gives you 1. Now, how do we deduce? We want to deduce the limit of tan x on x. So we want to deduce the limit of tan x on x as x approaches 0. As x approaches 0. How do we do this? Now you should also note that limit tan x is the same as sin x on cos x. So we can say limit of this is what? Sin x on cos x, all divided by x as x approaches what? Approaches 0. Now what happens here is that, what do we get here? You can say that the limit of the function as x approaches 0 is same as sin x, all divided by cos x, divided by x. So what we can say here is that if you take the division sign to be times 1 on x, and we can separate it and say limit as x approaches 0, sin x on x times, so we put the 1 on what? Cos x, which is the same thing. Now, if we separate the two of them and go to them individually, what we can say is that the limit of sin x on cos x is 1, as we established here. And the limit of cos x is also 1, which is also used. So that means we get 1 over 1 here. So if that is the case, that means the limit of tan x on x as x approaches 0 will also be equal to 1. So the fourth, the limit of tan x on x as x approaches 0 will also be equal to 1. But if we only consider the limit of tan x, which will do as x approaches 0, which will be sin x divided by cos x. So now it can be sin x on 1 times 1 over cos x, and this one will give you 0 times 1. So therefore the limit of tan x, 5. The limit of tan x as x approaches 0 is equal to 0. So these are the 5 simple trigonometric functions, the limit of their function you should put in mind. Okay, now let's take 1 or 2 examples and let's look at how we can tackle them. 1 or 2 examples, and let's look at how we can tackle them. So now the first example here says you should find the limit of sine of 5x on x as x approaches 0. Find the limit of sine of 5x on x as x approaches 0. So what you can do here is that now you have to find a way to make this down here also 5x. So now what you can do is that you can multiply the function by 5, the numerator by 5, and the denominator by 5. So when you do that, we get what? The limit of as x approaches 0 becomes 5 times sine of what? 5x divided by what? 5 times x, which is 5x. So now we get limit of x approaching 0, 5 into bracket sine 5x divided by what? 5x, and that is equal to sine 5x over 5x. Limit of sine of x divided by x, the same coefficient of the x is 1. So that means we get 5 times 1, which is equal to what? Is 5. Are you getting it? So we multiply by 5 from 5 because of what? The coefficient of the x that was here. Let's take one more example. Question 3 says to find the limit of cos x plus sine x as x approaches 0. The limit of cos x plus sine x as x approaches 0. So you know that, find the limit of as x approaches 0 of cos x plus the limit of as x approaches 0 of sine what? Sine x. Limit of cos x will give us what? 1 plus the limit of sine x will give us 0. So therefore the answer is what? It's 1. Okay. I like you to get a lot of questions and solve them, and you get a higher understanding of what we've been doing here. Thank you for joining this class.